Hey class, it's a new day, it's a new chapter, and this chapter is all about extending our concepts of perimeter, circumference, and area. So first thing I want you to do, just read the objectives from this lecture and give me a thumbs up. For those of you in class, of course, I'm going to see these thumbs going up all over the place. But when you're done with that, pause and go on. Okay, now that I got a thumbs up, let's just a quick review of some key vocabulary. When we think of base, of course, we're talking about the base of a figure, the bottom or the top, okay? And these are some of your vocabulary that you need for this chapter, but you may have already done them already. When you think about height, it's the vertical distance perpendicular to the base from one base to another. And altitude is the length from a vertex to the base. Actually, let me just do this real quick. So here, when I get a figure, we'll make it, I don't know, we'll just do something like that. We'll call, oh, it's a parallelogram. Look at that beautiful parallelogram. Great. This is a base and this is a base. This would be the height. When I have a triangle, something like that, my height is actually, I'll do it this way. Hey, that didn't work. My height is an altitude. So what I'm doing is I'm connecting a vertex to the base. So right, if I extended this line, you would see that that is my height. And that's what an altitude. A diagonal then connects two vertices that are not adjacent to each other. And those are some key concepts for this lecture here. So, area addition simply means the area of the whole is equal to the area of the parts. Now, you may recall that this looks vaguely familiar to what's called segment addition or angle addition. If I said, hey, from here to here is 5, and from here to here is 4, you would say, well, the total length, Mr. Rising, has to be 9. You're adding the parts to get the whole. Well, the same thing is true here. If you said, hey, if I want the area of this diamond or this rhombus, one way to do it would be to say, well, if I can figure out what the area of this triangle is, I can add it to the area of this triangle, and I'll get the entire area. One of the things you have to do is make this table. It's a graphic organizer, and it's the area formulas contained in section 10.1. And so it gives you, it says the area of one thing is base times height. The area of another is half base times height. So what I want you to do is go through section 10.1 and figure out all the shapes that use this formula for its area. And then give me an example. Put a little problem here. The same thing here. What uses 1/2 base height? What figure uses 1/2 the bases added together? So this has 2 bases times the height. And of course then this one, what figure uses the area is 1/2 the diagonals multiplied together. Okay, when you've completed that, come back and we're going to try some problems and you'll see how it makes sense. So I'm going to head to the board and do some problems with you for you. So the first one says the base of a parallelogram. So I want you to find the base of a parallelogram with a height of 56 yards and an area of 28. Area equals 28 yards squared. Okay, so again, the basis of a parallelogram. So it's saying find the base, okay? And it has a height of 56 yards. All right, so this height is 56. Well, once you've already completed your table, you realize, wait a minute, a parallelogram is just base times height. So the base times the height equals 28. Wait a minute, how do I solve for base? I'm going to divide both sides by 56. Weird. In this case, the base is equal to 1/2. So you see my original drawing? That is not anywhere near to scale. Really what I'm saying is, wait a minute, my drawing looks a lot more like something like that, where 56 is the height and 1/2 yard is the base. Okay, so this is a narrow strip. So don't let your drawing, don't get it so stuck in your mind that your drawing has to look the way it's supposed to until you actually figure out all your dimensions. The second problem says, find the area of a triangle with a hypotenuse of 20 and a height of 12. If you want to do this problem first, see if you can do it ahead of me. Good, pause the video and we'll do it. All right, find the area of a triangle whose hypotenuse is 20 and height is 12. Well, the moment it says hypotenuse, I know it's a right triangle. So I'm going to go like this. 20, 12. Area of a triangle equals 1/2 base times height. All right, area equals 1/2. I need to figure out the base. I know the height's 12. How do I do that? The square root, 20 squared minus 12 squared. Get out my old calculator, square root, 20 squared minus 12 squared. And of course at this point, I hope you all recognize the Pythagorean theorem, and I know what side C is. C is 20, so A squared plus B squared equals C squared, and I'm looking for this side down here, B, and I get 16. Now it's a simple matter of 16 times 12 divided by 2, and I get area equal to 96. So in these problems, you have to be careful because sometimes I'm going to give you the area and ask for a length. Sometimes I'm going to give you lengths and ask for area. You're going to have to really figure it out. Now, the last problem here. Let me scroll down. Will it let me scroll down? Come on, let me scroll down. Ooh, I do. Oh, look at that. I've got problems everywhere. Beautiful. I'm just going to do these 3, and I'm going to do 3 on the next page. It says, find the area of a right triangle. Let me get my picture out of the way. With a 40-degree angle and an adjacent leg of 78 feet. Again, if you think you can do this problem ahead of me, go for it. If you want to see how I'm going to do it, we'll just set it up. So, I'm going to have to scroll further like that, because that'll make it easier for me to do. I'll move my picture out of the way. All right, let me get my face out of the way there. That's much better. Get my big head out of the way. All right, here we go. Area of a right triangle with a 40-degree angle. Right? An adjacent leg of 78 feet. Okay, so again, 40-degree angle, adjacent. What I really need to find is this side right here, the opposite. So again, hey, don't forget SOHCAHTOA and your trig ratios. The tangent of 40 equals O opposite over 78 adjacent. So we'll just multiply both sides by 78. So 78 times the tangent of 40. And oh, lo and behold, my opposite side is 65 point, let's call it 45. Well, the reason that's such a wonderful thing is now all I have to do is 1/2 or 0.5 times 78 times my answer. Let's see if you can see my little calculator there. Look at that. A little bit of a glare. Ta-da, right? And I get, okay. So area here, 2.5 feet square. Again, length is 1 dimension, area is 2 dimension, and volume is 3 dimensions. I just want to show you a couple more problems. I don't really want to bore you to death. But I want to show you other figures and how the formulas that you came up with here apply to problems like these. So this figure here, first of all, you recognize this as some sort of sideways figure. Well, that's correct. This is called a trapezoid because it has a set of parallel bases. You'll notice the left and right side are parallel to each other, but they're different lengths. So these sides are different lengths as well. Now let me just also note these are 90 degrees, right? They're parallel. And now the formula for the area of a rhombus, of course, you're all screaming at me. I know, Mr. Rising, area equals 1/2 the sum of the bases times the height. Now all I have to do is substitute what I know. All right, 1/2, base 1 is 9, base 2 is 15, and the height is 20. If I could actually write that, that would be helpful. Now, remember when you multiply things together, things get a little easier. So actually, I can multiply this 1/2 by 20 and get 10 right off the bat. So 9 plus 15 is 24. 24 times 10 is 240. So the area is equal to 240 units, whatever that is, squared. Now, the next two problems here, let me put my marker down, move my face out of the way. Right? So the next two problems here, this is supposed to be a rhombus, and this is supposed to be, it's pretty scary looking, but it's supposed to be a kite. All right, so let's go ahead and work this out. The first one says find the area, and I know that this length here is 25. Well, actually, they're all 25. Okay, all four sides are 25 because it's a rhombus. And what's interesting is when I do this on the board, it looks like a rhombus. When I do it on this side screen, it looks kind of squished. But anyway, so anyway, all these are 25. But what I really need is this diagonal right there. And boy, how can I get that? Well, let me just go back a second and think. If this whole length is, if this length here is 14, this is really 7. And this is really 7, right? And I also know this part here and this part here are the same. So really, one way to do this is, I have a triangle. Let me just highlight it. I've got, we'll do this one here and go whooshoop, 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 right? So I've got a 7, 25 something triangle, and I can actually figure that out pretty easily. So 25 squared equals 7 squared plus this length squared, right? And again on my calculator, the square root, 25 squared minus 7 squared, and I get 24. So this length here, let me use yellow, this is 24. So now, what's the entire length across the other diagonal? Well, the other diagonal is 48. Okay, area of this is 1/2 diagonal 1, which is 14, times diagonal 2, which is 48. And I get 336 units squared. Right? So I just worked that out into pieces. All right, I've got one last problem. I've got a little bit over a minute. It says, I know the area of this kite. I know this diagonal is 15. Find the other diagonal. Well, they just want you to do this problem backwards. So again, I'm trying to find this diagonal here. 187.5 equals 1/2. It's a kite. Diagonal 1 times diagonal 2. So really, what I need to do is multiply both sides by 2 and divide by 15. Multiply by 2, divide by 15, and that will cancel those out. And I'll put them over here. So I've got 187.5 times 2 divided by 15. And I get diagonal 2 equals 25. Hey, you've got some problems to do. I hope this lecture helped and gave you some examples, and I'll see you on the other side.